To demonstrate how we do it, we use this very high-level description to highlight the design specifics. We use the memory, that is the ROM, to store the sprite file of pictures to be used in the game. Different interactive modules like level, store are synchronized by a 25 MHz clock, which is corresponding to the frequency of the VGA monitor. So the clock divider is acting as a clock signal. The function of the clock store is to store the game and resume the game using a resume switch. The key interaction of this game is among the panda, evil dragon, weapons, and ground. To let the game run smoothly, the detection of those modules has to be accurate. Basically, the fundamental idea is using the mathematical representation to produce some control signals that indicate whether some certain number of modules hit together. For instance, while the bullet hit the panda, it could be deduced by whether the boundary of bullet is overlapped with the boundary of panda. But while those boundaries are constantly changing, that poses a critical challenge to our design. Besides, the sound module works by selecting different frequency to be sent to the speaker. The different combination of frequency consecutively is actually what makes the background music you hear. The pseudo random number generator let the ground, coin, and star module to appear in a statistic fashion. So basically, all those modules combine together to manipulate the pixels displayed on the monitor, and that is what makes our game what it appears to be like.
We found it boring to have a regular line form, so we decided to make it random shaped. My idea is like this. Firstly, generate 3 number arrays, H1, H2, and H3. H1 is set to 0 initially, H2 is to 320, which is the middle of the screen, H3 is to 640, which is the right end of the screen. Basically, these 3 move left in some way as a design to form the line shape, as this. In this way, as clock goes on, the ground goes from right to left, and when any one of H1, H2, and H3 becomes 0, it gets value of 640 and keeps 640 until the next H becomes 0. As you can see, there are 3 cases. First, H1 is bigger than 0 and less than 320. Second, H3 is bigger than 0 and less than 320. Third, H1 is bigger than 0 and less than 320. This is the code that implements this design. To implement the ground, I just need to give the height value in this module. In this module, I applied a random ground height number under every case. Then the ground would be like in the game.
Here is edge detection of ground. As we all know, edge detection of ground is an important part of our project. The height of ground changes every clock cycle, and the vertical length and horizontal values change as we said before, so it is much harder to detect the edge they are fixed ground. Here is what I have done to solve this problem. Looking at the picture, first we assumed the panda stands on one of the ground level. This picture shows it stands on first level. Then we have to compare the height of the current level and the coming level. These pictures show second level higher than first one. The panda has to jump, or it would be die by collide with the higher edge. In a level condition, the panda would stand on the next ground level safely. Listing all the conditions, the edge detection of ground would be done. Now we are moving to the sound module. As we all know, different sounds are different frequency. If we could write a program that could drive a single pin from FPGA with different frequency, the sound will come out from the speaker. There are two important parts of sound. There are notes and rhythm. For notes, we can get different frequency of different notes from a basic frequency. In this program, I choose 1 MHz as a basic frequency, and I also choose the initial counter to help me divide each note in their desired frequency. For example, the do in note, its initial count is 273, and I put the initial into this divider. It will divide the do into its desired frequency. For rhythm, in this program I choose 4 Hz as a basic rhythm, which means that every 0.25 seconds a note will come from the speaker. And these are the notes of background music in our program, and every note in this program is transferred into battery, and with the help of the initial counter we can get our desired frequency, and this is our sound module. We are going to introduce animation. Firstly, we show the changing pictures by using several IP cores to build some ROMs. But in this way we have to access different memory very frequently, which sometimes resulted in errors in display. So we draw related pictures in one picture and convert it into VOE files. We only need to change the address of the memory since we know exactly where the next picture begins in the ROM.
So this is our body design module. We have two challenges in front of us. The first one is how to capture the position of panda which is moving. Another challenge is how to start the bullet when the bullet reaches the right side of the VGA monitor. So the way we do it is to set up two control signals. The first one is an internal control signal which decides the moving time of the bullet. Another control signal is an external one which will be provided to the top module to let the top module decide whether to display the bullet or not. This Verilog code, we set up several registers to receive the position information of panda and two other signals to act as the control signals. The first assignment choose the HPBU, which is the position of the bullet, depending on the value of the flag, which is initial 0. The second assignment let the external control signal TB signal to be decided by whether the bullet reaches the right edge of the screen. The 799 comes from the horizontal synchronized time of VGA retrace time. So in this way, the bullet successfully reached the edge as we expected and stopped as we anticipated. In order to let the register receive the value of panda position, we take advantage of the always block to let the register capture the information of the panda. But the second always block that the counter of the bullet increases as long as the internal signal is 1, otherwise it will be reset. The third always block determines the internal control signal when the bullet horizontal position reaches the right edge of the screen.